Hello everyone, welcome to the Problem Solving Penguarium, where we solve problems better. Today in episode 4 we're doing a Year 9 style question for measurement and geometry. And let's get straight into it, and first of all let's clarify the question. So Julie has a piece of wood that is a rectangular prism, 4 centimeters by 4 centimeters by 3 centimeters, and that is clearly shown here in the diagram as well. She cuts the wood into small blocks, each 2 centimeters by 1 centimeter by 4 centimeters. How many small blocks can Julie cut from the large piece of wood? Okay, so the question is asking us how many of these small blocks will fit into the large block. Okay, now in terms of choosing a strategy, they've already drawn a diagram for us, so let's work with that one. And that'll help us sort of visualize what we're looking at rather than just dimensions. So let's get straight into the views. Okay, so first thing I'm going to do is I'm going to draw the second little block. Okay, I'm going to draw what she's cutting them into. And I'm going to call the first one block 1, and I'm going to call the second one number 2. So the dimensions on the second one, let's say that 2 centimeters is at the bottom there, 4 centimeters is the length, and 1 centimeter will be the height. Okay, so I have my 2 blocks. How many of block 2 can fit into block 1? Now when we're working in volume, I'm just going to come to the side here for a moment, I'm hoping at this stage that we understand that area is always written as units squared. Okay, and that's because we're measuring, we're using 2 dimensions, we're using length times width. If we go back to perimeter, okay, we never write it as squared, we just write it as units. However, I remember it as units 1, or one dimension of units. Okay, so when we jump to volume, when we jump to volume and we're multiplying 3 dimensions together, we end up having units cubed. Units cubed. So I remember it as units 1, units 2, units 3, 1 dimension, 2 dimension, 3 dimension, perimeter, area, and volume. Okay, so I want to work out, I think the easiest way to do this will be to work out the volume of the 2 shapes, of the 2 blocks, and then divide them from there. So let's work out the volume of block number 1. So the volume of block number 1 is equal to the length times the width times the height, or the depth, depending on how you want to call it. And that would become, so let's say the length was 4 times the width is 4 times 3, which is 16, times 3, which will be 48. Now, units cubed, centimeters cubed. Now notice I didn't put in my centimeters, centimeters, and centimeters, which was a bit lazy of me, so I need to include them to ensure I get the top communication marks. So centimeters 1 centimeter, 2 centimeter, 3 centimeter, and that all adds up and multiplies up to be centimeters cubed. Okay, for volume 2, again, stating formulas, length times width times height equals 4 times 2 times 1 equals 8 times 1 equals 8 centimeters cubed. Again, I forgot to put my units in, that's very lazy of me. Okay, so now I have the volume of the large prism and the volume of the small prism. Okay, now thinking about it, if I have a large volume and I divide it by the small volume, that should give me how many of the smaller prisms, the volume number 2, so number of V2, that can fit into V1. I'll write this one out, into V1. Okay, so let's do it. 48 centimeters cubed, I remembered my units, divided by 8 centimeters cubed equals, okay, 48 divided by 8 is going to be, what's that, 6. Okay, centimeters cubed divided by centimeters cubed is going to be 1. They're essentially going to cancel each other out. If you think about it like this, 2 divided by 2 equals 1. A divided by A equals 1. So centimeters cubed divided by centimeters cubed will be 1, which will mean this will be 6 times 1, which will just be 6. Okay, so it's important to remember that our answer is not 6 centimeters cubed, okay, we're looking of how many volumes of volume 2 can fit into volume 1. So our answer is going to be 6. So it's not going to have the units attached. So in terms of checking our work, how can we do this? Well, we can check our calculations, and we can do 8 times 6. We can do 8 times 6 equals 48. Let me just check that on the calc just to be sure. In fact, where is it? Calculator. So 8 times 6 equals 48. Good. But we could also think about it visually in terms of how many of volume 2s fit into volume 1s. And we could work out if they're 1 centimeter high, we could stack 3 high. Okay, if they're 2 centimeters across, so let me fix that up. 2 centimeters across would be halfway. 3 high and 2 across, and they're already the whole length. So yeah, that fits. Okay, so the answer in this case is going to be B. Finally, in terms of our conclusion, it's multiple choice, so in this case we'll just circle the answer. But if I was to write, if I was to conclude properly in a written exam or a written context, it would be something along the lines of Julie would be able to cut volume number 1